In this section, we are going to discuss valence electron, formal charge, and reaction mechanism. So let's write down here so that you all know this is the valence electron. We're going to define valence electron. Then based on valence electron, we can calculate formal charge, which is extremely important in organic reaction. And then we talk about reaction mechanism, especially how charge gets developed in reaction product formation. So we are going to talk about these three, and also we talk about a few homework problems. Now, in order to understand this positive negative charge development, I'm going to write one organic formula on the right, and let's see whether I can calculate formal charge on oxygen or carbon in that compound. So this compound is CH3, and then you have CH2, and then OH2. Remember, I said that if you have an element other than hydrogen, then it would like to have 8 electrons. So first we have to take care of that. Now the oxygen doesn't have 8 electrons, so you need to make it 8. Now, if I give you this structure and I ask you, is this a neutral molecule or not? If it's not neutral, assign positive or negative. So for that we need to examine charges around or number of electrons around certain centers. Like for example, we can look at around this oxygen. Let's put an asterisk here around this oxygen. Now this oxygen has 2 unshared electrons and rest are all shared electrons. So in formal charge calculation, shared electrons, you take only half of that. That means even though there are 2 electrons here, you consider it to be 1 would be the share of oxygen and the other one would be share of carbon. So now let's count all together what we have around oxygen. So 1, 2, 3 electron because of the share, and 2 are solely on oxygen. So there are 5 electrons on oxygen. Now let's look at valence electron for oxygen. Let's figure out location of oxygen and calculate formal charge. This is oxygen. In order to get valence electrons, you need to count from the beginning of that line until you reach oxygen. So the line begins here. So it'd be 1, 2, then third is boron, 4th, 5th, 6th. So oxygen has share of 5 electrons, but its valence electron is 6. So let's write down valence electron equals to 6. That means it's supposed to have 6, but it has 5. That means it's lost 1 electron in the process of sharing. What that means is oxygen must have +1 or just simply plus. So if you see in reaction mechanism something like this, before it gives final product, you must assign +1 on oxygen. Now let's count around this carbon. Is that carbon neutral or has positive or negative? Now again, these are all bonded pair, so you get 1, 2, 3, 4. So carbon has 4 electrons in this compound, 4 shared electrons. That means I'm talking about the 4 electrons that's share of carbon. Now think about valence electron for carbon. How many electrons is supposed to have? Now this is carbon. Again, you count from the beginning of the line. So 1, 2, 3, 4. So carbon has 4 valence electrons. It's supposed to have 4 electrons, and it does have 4 electrons in this compound. That means it didn't receive any extra electron or didn't lose any electron during the sharing. That means formal charge is 0 for carbon. So in other words, the charge development of +1 is solely due to this oxygen that has plus or +1. Now This is the typical reaction, organic reaction, where charges are often shared between, electron pairs are often shared between one element to another. Like in this case, alcohol is reacting with HCl. Electron pair from oxygen goes on to hydrogen because it would like to make a bond with hydrogen. Now, question is why? Can we understand that? HCl would have hydrogen at the polar bond. Hydrogen would have the positive end, so let's write down delta plus, and Cl would have the negative end, delta minus. Now, why is that? Cl appears on the right hand side of periodic table, so it's more electronegative than hydrogen that appears on the left hand side. So electron will be pulled towards Cl, making it minus, and hydrogen will be plus. So obviously this electron pair on oxygen would be attracted towards this positive end, and that's why it would like to donate its electron pair to hydrogen. But the problem with hydrogen is, hydrogen, if it accepts electron pair from oxygen, it has to give up this electron pair because it cannot hold on to two pairs of electrons. So, and that's exactly how this reaction happens. When this electron pair, it receives from oxygen of alcohol, it breaks this bond and gives this its electron pair onto Cl. So Cl gets separated. And we just have shown you that CH3CH2OH2 gets a plus or plus 1 charge. That's the formal charge. Now, can we understand that why Cl is minus 1? Yes, you can write down 8 electrons around Cl. So in this particular case, you have 8 electrons. Now look at periodic table and find out what's the valence electron for number of valence electrons for Cl. You'd find it's 7. Again, you count it from the left hand side of the line until you reach Cl, and it finds 7 electrons. So that means Cl, this is valence electron, is supposed to have 7, but it has 8 due to sharing of electrons. That means it has an extra electron. That's why Cl gets minus 1 or just minus, and that's why we assign negative on Cl. Now we are going to do a few homework problems, so make sure you understand them. First, we are showing you formation of AlCl3. Al comes from group 3A, so it's plus 3. Cl is from group 7, it's minus 1. So when you make this compound, Al with plus 3, Cl with minus 1, so this 3 goes down here and 1 goes here, so get AlCl3. Now next we're getting organic compound, CF2Cl2. Again, carbon must have 4 bonds, and that's exactly, we have assigned 4 bonds, and then we do have 4 different elements. So you just stick in 1 element to each bond, and that's how we got this compound. The third one also is fairly easy, nitrogen with 3 bonds and 1 unshared electron pair. We already mentioned to you this, that nitrogen, neutral nitrogen must get 3 bonds and a pair of electrons. That gives 8 electrons around nitrogen. So this is the answer to part C. I think this is the problem number 33. Here we are supposed to draw Lewis structure and assign electron pairs. Again, you'd be fast in drawing these structures if you know that carbon must have 4 bonds, and that's how we got this carbon with 4 bonds. We got this carbon with 4 bonds, but oxygen can have 2 bonds, and that's what you see here. In addition, you must assign electron pairs because oxygen must have altogether 8 electrons. With 2 bonds like these, it has 4 electrons, so I need 4 more electrons. Okay, so that gives 8 electrons around oxygen. Now in part B, you have again nitrogen with 2 hydrogens, and obviously you must have 1 pair of electron. So that gives 8 electrons around nitrogen, and nitrogen also has 3 bonds. This carbon has already 4 bonds, so I don't need to do anything. In this slide, we're going to show you a reaction, and the question is, does a reaction like this happen? How would I be able to predict that? pKa values are given, and that should give you an idea whether a reaction like this is going to happen or not. Remember, we mentioned that a smaller pKa value means stronger acid. So this is a stronger acid. Now, stronger acid means it wants to donate its hydrogen as H+. And in this reaction, that's exactly what it does. That for which, from this compound, you end up with this compound, that last one, H+. So between these two, since this is a stronger acid, and in this case, you are seeing that this stronger acid is losing its H+, and NH2 minus is absorbing that H+, or grabbing that H+. And so reaction like this is going to happen. Now, on the other hand, if this were a stronger acid, or pKa value was lower, then reverse reaction would be happening, but the forward reaction will not be happening. Now we are going to do a few other homework problems. I'll first work on problem 1.8. That's chapter 1, number 8. Basically, they're asking you to write down tetrahedral representation of a particular molecule, which is CCl4. So let's write down CCl4. So by using a standard convention, we're going to write down first C and 2Cl at an angle. Whenever you have a solid line like this, that means C and 2Cl are sitting on a plane. If you have molecular model, you can readily see that. You can always place two of these bonds on a plane of paper, and you'd find that if you place it on a plane of paper, one of the bonds would be projected towards you. So I'm going to write down that in thick line. So it's going to be like this. That's projected towards me or towards you. And when you do that, you'd find that the fourth bond would be away from you. It's shown with dashed lines or dotted lines. So this is the tetrahedral representation in standard manner, where you have one bond towards you, two bonds sitting on the plane, and one bond is behind you or behind the plane of paper. So hope you now understand this standard representation. Next problem that I'm going to do would be 17E. Let me first draw this CH3, and then you have MgBr. Question is, what is the direction of expected polarity? So direction of expected polarity, for that they have assigned a bond. So first focus on these elements which are bonded, C and Mg. Just by looking at periodic table, you'd know Mg is from left hand side of the periodic table, so it must be less electronegative or positive, assign a positive sign. Since carbon is on the right side, it's more electronegative, so assign a delta negative. If you want to know the electronegativity value, you can look it up in electronegativity table. That would give C 2.5, so it's 2.5 is electronegativity value, and 1.2 is the electronegativity value for magnesium. So these are electronegativity values. You don't have to get those values, but if you want, you can do that. So this confirms that carbon is more electronegative, so negative is on this end, positive is on this end. Now, direction of polarity would be from positive towards negative. So that's the direction of polarity. This is also the direction along which electron pairs would be shifted because of greater attraction towards carbon. This is also called organometallic bond. So metal is positive charge and carbon has a negative charge. So keep this in mind. Now we're going to do number 38, chapter 1. So this 1.38 is basically asking us to write down two structures of C4H10. So C4H10 is a formula. So they're asking you to write down two different structures. Remember, structure tells us how they're bonded. So you cannot have two compounds with same structure. Now, first I'm going to write down all the carbon. 3, 4 carbon. All back to back. Now, each carbon must have 4 bonds. 1, 2, 3, 1, 2, 1, 2, 1, 2, 3. So now stick in hydrogen, and you find that that would satisfy C4H10. This N has 3, then 4, 5, 6, 7, 8, 9, 10. So that checks out. Now that's one structure. My next structure, again, it'd be a lot easier to think if you write down first carbon. 1, 2, 3. I cannot write down the fourth at the end because that would be same as this. So I must have a branching. That gives the fourth. Now you fill in with hydrogen. Now, I don't have to now write down like this. I can just write down CH3. Keep that in mind. This is called condensed formula. You just save your time. CH3, CH3, and just one hydrogen here. So keep in mind, I'm writing down these 3 hydrogens like this. So now you have CH3, CH, CH3, CH3. Now you can always double count 3, 6, 8. I think I have one extra one. 3, 6, 7. I'm sorry. So this is 3, 6, 7, 8, 9, 10. Yeah, I'm right. I'm sorry that I miscounted. Now, I can also write down these structures as follows. In many books, they write down like this. So let me explain that to you. 1, 2, 3, 4. Sorry, I have one extra one here. Each corner represents a carbon. So 1, 2, 3, 4. So people often write down carbon without showing hydrogen, but then it's kind of expected to know that they have hydrogen. That means this end must have 3 hydrogens, this end has 2, this has 2, this is 3. Now how do I write down this structure? Like this. Again, each corner represents a carbon. So 2, 3, 4. Rest would be all hydrogen. Like you need 3 hydrogens here, 3 hydrogens here. Only 1 hydrogen for this because you have 3 bonds already. So now you have 3 hydrogens for this. So if you see this kind of structure, don't get confused, or this kind of structure. Now why is it shown like this? Because this is sp3 hybridization, so angle is not 180 degree, so it's 109.5, so you draw like this. This is the Lewis structure, so we didn't write down, when you write down Lewis structure, you don't care about the shape, but here we are also trying to give the right shape. So either one would be fine.